Welcome to another episode of Nautical Sciences. Today we're going to be talking about undersea landscapes. For a long time, mariners didn't really know what it was like underneath the sea. They just took a look at the water, they said it looks pretty smooth. They just thought everything under the sea was just like a big sand bed and it just kind of swallowed up everything. Well, around World War One, they invented submarines, and understanding of what it was like underneath the seas became a lot more important. Today I'm going to get you a little bit familiar with some of the terms that we use to describe the regions under the water and hope to understand a little bit better the importance of the sea on maritime strategy. Start off with a quick definition. Topography is the study of the relief of the earth or different elevations in the form of its surfaces. Now we can study topography of the continents and land, or underneath the sea is the same way. Relief maps can show the elevations of mountains and surfaces on the earth. But as you can see, the area underneath the water, we're taking a look at a relief map right now. And it's just like on top of the land. Lots of different mountains and ridges and things like that. So the relief maps can be on the land or on the sea, but we're talking really about underneath the waters today. Now, the two main areas of the Earth are the deep ocean floor, as we're looking at here, also known as the deep sea, and then really the only other region is the continents. Now, the continents also includes this area called the continental shelf, which is underwater, but it kind of is an extension of the continent. 71% of the Earth's surface is water, but only about 2/3 of the entire Earth, 66%, is truly the deep sea. So why is that important to understand? Well, if you really want to get underneath the water, like submarines do, this is where they operate on a day-to-day basis. They have no windows on submarines, but they have to be able to navigate through all of these different ridges and things like that. How do they do it? Well, they can't look out, so they use an instrument that was developed called an echo sounder, or fathometer. It sends out a sound wave and records the time it takes to hear the echo. The instrument knows exactly how far it is above the ocean floor. Sound travels about 4,800 feet per second in water. It bounces off of something, and then it comes back up. The fathometer can count the number of seconds there and back, divide by 2, and do the calculation to determine the height above the ocean floor. Simple physics. Depths are usually given in fathoms, which is why we call it a fathometer. And fathom is 6 feet of water. It's something that was developed a long time ago in the early seafaring days. A fathom was measured on a length of rope that was put into the water to determine how deep the water was. And they, instead of measuring by feet, they measured it from fingertip to fingertip of the outstretched arms. So as we zoom out now and head over to the Gulf of Mexico, an area that's kind of known to us, it's different than the deep sea. You'll see a lot of the continental ridge that extends out from the ocean. Now the continental shelf is really the area of the continent, but what we do is we divide that up into different regions. The 12 nautical mile range is called the territorial waters. It's just kind of said that that's where you can control shipping. It's kind of an extension of your home country. International treaties and agreements have established an area called an exclusive economic zone. The country has exclusive rights to use the resources in that area. Resources like oil, drilling, fishing, different things like that are claimed by the country. They can extend no more than 200 nautical miles from the shore. This is only the area underneath the waters. It doesn't mean on top of the waters. As I said, the territorial waters go out to 12 nautical miles, but underneath the waters you can use fishing and oil drilling and things like that. Now, it's much easier to get things out of the shallower waters. It's also closer to the country. So, why do we establish this? Well, if Russia wanted to come in and say, I'm going to drop an oil rig right here next to Florida, and all that's mine now, well, you'd probably come up in some pretty big conflicts, right? So these exclusive economic zones try to avoid these conflicts. Some areas like China have been trying to push their exclusive economic zones, trying to claim different areas, claim their entire continental shelf. And that can certainly lead to conflicts and wars if you're not careful. So we've established these treaties internationally to try to avoid those kind of things. So how far is 200 nautical miles? Well, pull up a ruler here. Take a look, let's say from Louisiana, right? And we start here at the coastline, continue out to 200 nautical miles. You know, that's probably pretty far, almost to the middle of the Gulf of Mexico. What about someplace over here, like between Florida and Cuba? You know, if we start here and draw a 200-mile line, you know, that's going to go through Cuba. So once again, those international treaties have said, you know, this is the United States up here, that's their continental shelf, this is the Cuban continental shelf, and we'll draw a line between the two and split them. In the United States, due to Alaska, Hawaii, the protectorates, they actually have the largest exclusive economic zone in the world. All right, so back to the deep sea, we're going to talk a little bit about the formation of some of these islands. Most of the islands in the deep sea are volcanic islands. Just like a volcano on the shore, the force of molten lava pushes up on the crust to form a mountain. As we zoom into Hawaii, we'll take a look at, you know, a large crater, but then some of the smaller craters that have formed. You can kind of see a large crater that's here. Well, all that force of the lava coming up is pushed up into making this this whole island. And you can see some of the smaller craters that have formed over the years of different eruptions, but it's all based on one large crater. We don't always get that much force creating large islands like that. We have things called seamounts, which are pretty much the same thing, smaller islands that have never broken the surface. Another form of seamounts is called a guyot. It's a smaller, or it's not really smaller, but it's a seamount that is a flattened top. It's usually not an active volcano at it. Now, if a volcano comes up and it just barely breaches the surface, so that just the ridge of that volcano goes over the surface, it's called an atoll. As you can see, this ridge and this big volcano in the middle here, just bridging the surface. Do you remember another atoll that we talked about in one of our previous episodes? That's right, Diego Garcia, all the way on the other side of the ocean, or other side of the world. This one has a very good, well-defined ridge, but you can see it's probably several volcanoes that had formed millions of years ago. This was just a short overview of some of the terms we use to describe underwater geography. Above the water can look very calm and smooth, but under the water, it's just as varied and interesting as all the land you see on the continents. We talked about different regions under the water, some of the terms used to describe the features. As we move on in our lessons, we'll learn more about some of the geography and how to use that geography to the advantage when planning military operations or how it affects strategy. We talked about like the Dardanelles and British invasion during World War. You know, not knowing a full understanding of geography and surf regions and things like that can definitely affect whether or not you are successful in certain operations. So hopefully I've given you a quick overview. We'll continue to study it a little bit more in the next region where we learn more details about some of the regions closer to the lands.